Hello, everyone. In this episode, we'll see how to use Keras embedding layers. So go to Google Notebook and Google Colab. So here are the embedding layers. It usually is used in natural language processing. It basically tries to fit some vector to a different dimensional vectors that's usually embedding. For example, the word could be 300-dimensional vector, and you can shrink it down to, I don't know, 10 embedding layers or the other way around. And you can see that it's often used in natural language processing. So here, the layer example, it takes three numbers: input dimension, output dimension, and input length. Input dimension is the original, let's say, the number of vocabularies or categories. Like, for example, if you were to deal MNIST handwritten digits, they have 0 to 9 digits, so the 10 numbers. So 10 would be your input dimension. And suppose that you want to represent those 10 digits into 4 different or 5 different numbers, then in the word embedding, then I guess miscounting that. If you have 4 categories, then it would be 0 to 3. The output dimension would be 4. Okay. And the input length is basically how many of those vectors come in. So the 10 digits, they're converting to 4. How many of those do you want to put in? You can do this. So here we'll consider a neural network with vocabulary size of 9 to reduce the values of 0 to 8 to 3 different numbers. Okay. So let's load the TensorFlow. So basically, this is a way to have, let's say, 10 numbers or 9 numbers here, shrink it down to 3 numbers, okay, using a neural network. And you will see why we want to do this. So here's a Keras model sequential, the input dimension 9, and embedding layer, output dimension 3, and input length of 4. So it takes 4 of such numbers. And embedding layer. So this is a very simple network. It does really do nothing except shrinking those to 3. So it's shrinking the 9 numbers to 3. So they have 27 parameters and 4 numbers will come out. Okay. So 4 numbers here. 1. So each number has to be between 0 and 8, isn't it? Because it has 9 plus categories. So the first input data was category 1, then category 2, category 6, and category 3. So that's the 4 input information coming in. You put that in that model we just had and predict, and it will spit out this. For this category 1, it converted. So the possibilities were from 0 to 9. And it converts down to 3 numbers here, isn't it? So the 1 was converted to this, 2 was converted to this, and then the 6 was converted to this, and 3 was converted to this. In fact, you can see the whole weights of the neural network, and then you can see that the number 1, which is the second, so 0, 1 is identical to this, and number 2 is the third one, this one here. And number 6 is 1, 2, 3, 4, 5, 6. This one, no, this one. Okay. Then what was the last one? 3. This is the fourth one. 1, 2, 3, 4. So this is the fourth one. Okay. You can see that it basically converted the neural network, transformed these numbers 0 to 8 into the 3 number vector. Okay. So why would you do this? So here's an example of doing it. So for example, if you want to transform the values 0, 1 to 3, there are 4 categories into one hot encoding vector. Again, I think there's a typo, I apologize. Okay. So how do we do this? So here's an embedding lookup table. So here's the 100,010 and the 0010,0001. So we put a sequential layer, embedding input dimension of 4. There are 4 numbers, and output dimension is also 4. We want to convert the 4 numbers down to 4, isn't it? So how do we do this? So here's the embedding layer. So what does this do? For example, we give a number 0 and 3. So 0 corresponds to 1000, and 3 corresponds to 0001, isn't it? So using this neural network we just had, look what it did. It converted the numbers into this one-hot encoded vector. That's a very neat way of using this embedded layer. It automatically converts this classification into one-hot coding vector, and you don't have to write this scikit-learn or wherever you do these packages. You have your own package. Here's a training on embedding. So there are kind of the market conditions, okay? And you want to convert it to a vector. Okay, so here, so the labels are, these are the positive. So there's a super crazy booming market, fantastic market, bullish market, positive. These are all positive statements. Let me make it positive here. And then the lukewarm, boring market, negative, bearish, terrible, market crash, absolute panic. These are all negative news, isn't it? So can we train? And then let's have a vocabulary size of 30. You can have it. So there are only 10 market conditions. I define more words. It will just be redundant, so you don't have to worry about it. Okay. So the vocabulary size of 30, encoded market, 1 hot of vocabulary size of the review. Basically converted the 30 words into these kind of, it converted it. Okay. The TensorFlow one-hot encoding method. Okay. And then the program will convert the pad sequences. So we pad it into this. Now we put it into embedding layer. So we padded these 3, 1, it's here, 26, 18, and then we padded with 0. So we had all these market conditions be here. Then what we do is that we have an embedding layer of vocabulary size 30, go to 8. Maximum length was how much? 4. Okay, so we've converted to 4 numbers in this embedding layer. So we have this embedding layer and then a dense network of sigmoid. So what does this do? So it basically accepts 4 integer inputs that specify the indices of the padded movie review. The first embedding layer converts these 4 indices into 4 vectors of length 8. The vector comes from the lookup table of contains 30 rows of vectors of length of 8. Then the output size of the embedding layer is 32. 4 words expressed by 8 number embedded layers, and then puts out here. So let's fit that. Okay, it does it rather quick. And then what does that do? Well, it basically does have the embedded learning of basically translated into 1, 2, 3, 4, 5, 6, 7, 8 numbers for each of these categories. Okay. So, and now we put that movie review, and then how does it work? Well, it's kind of overfitting. So, but you can see it's not perfect because it overfitted. So the loss is actually not 0. But this is another way of showing how to use the embedding layer. So and there are various uses, but I just wanted to introduce this embedding layer, which is originally used in NLP, natural language processing, but it has other uses that are useful too. Thank you for watching this video.